Welcome to part 1 of the series of videos on computer science with Python based on CBSE curriculum for classes 11 and 12. Part 1 covers tokens and data types in Python. Firstly, what is a token? Token is the smallest unit in a Python code. This is also known as a lexical unit. There are different types of tokens. To list them: identifiers, keywords, literals, operators, and punctuators. Now let's look at each one of these tokens in detail. Firstly, what is an identifier? Identifier is a user-defined name that's used to name a variable or a function in a Python code. Like for instance, I have an expression x is equal to 5. The x is the name of the variable or the identifier. So there are certain rules that we need to follow when such an identifier name has to be framed, and the rules are: it should either start with a letter or an underscore. It should not start with a digit, but it can contain digits. It should not have any special symbols other than the underscore. It should not have spaces. It should not be a keyword. And identifiers are case sensitive. So like what's shown in the example, the same identifier SNO is shown in different cases, and they're all going to be treated as different variable names. Examples of valid identifiers are what's shown there, and examples of invalid identifiers. Now why these are invalid? The first one, date of birth, is invalid because it has embedded blank spaces. The second one has a digit in the beginning, it starts with a digit. The third is a invalid identifier because it's a keyword, and the fourth is invalid because it contains a symbol, a special symbol. The only symbol allowed in an identifier name is a underscore. The next token is a keyword. Keywords are reserved words which have a special meaning and purpose. They cannot be used as an identifier. When we start doing codes in Python, we'll get to know different keywords and their purposes. A few examples have been shown here. To see the list of keywords in your version of Python, there is a library which you can import. Now more about libraries and importing a library we'll see in the coming videos. There is a library called keyword. You import the library and then you go on to type keyword.kwlist. This will give you the list of keywords that are found in your version of Python. So each of these keywords have got some special meaning and purpose. And like what was told earlier, a keyword cannot be used as an identifier. The next token is a literal. Literal is a constant which does not change its value during the program execution. There are different types of literals in Python. Numerical literal. A numerical literal can be either an integer or a floating point or a complex numerical literal. A Boolean literal, a string literal, a list literal, a tuple literal, a dictionary literal, and a special literal. Now we'll see each one of these types with examples to understand better. A numerical literal can be, like we saw, there are three integer literals, floating point literals, and complex literals. An integer numerical literal can in turn be represented in 4 forms: the decimal form, the octal form, hexadecimal form, and the binary form. When you have a negative sign preceding the number, it refers to the negative of the number. When you do not have a sign preceding the number, by default it is treated as positive. So the number can come with or without the sign, but definitely it should not contain a decimal point. Now in a decimal form notation, just the value is to be represented, but in a octal notation form, the value has to be preceded by a 0O, and in hexadecimal form it has to be preceded by a 0x. In a binary form it has to be preceded by a 0b. Now when you use one of these notations in your Python expression, it will automatically be converted into a decimal notation. Like for instance, if I have a variable assigned with a value 15, just the value with no other representation before the given digit, this is going to be a decimal notation. If I print the value of x, 15 that is stored in x will be displayed. But if x is assigned with 15 that is preceded by a 0 O, then this is no longer decimal 15, this is octal 15. Octal 15 is 13 in decimal notation. This we must have learned in chapter 2 of 11th standard, number representation, where all the 4 forms are introduced, integer form, binary form, octal form, hexadecimal form, and how to convert one number system to another. We have learned this in the 11th standard, and using that same procedure or algorithm, you can check out 15 to the base 8 is 13 to the base 10. If I have the same x assigned with a 15 preceded by a 0 x, then that will be treated as the hexadecimal 15, whose corresponding value in decimal notation is going to be a 21. If the variable x is assigned with a valid binary number, let's say 1101, and then you try to print the value of x, we can see a 1101 in base 2 is 13 to the base 10. So all these notations are to represent an integer numerical literal in Python. A floating point numerical literal is that which has a decimal point. Again, it can come with or without a sign to represent positive and negative numbers. A floating point number is in turn represented in 2 forms, the real form and the exponent form. The real form is going to be a series of numbers with a decimal value with or without the sign. The decimal point need not be embedded. Like in this case, we can start with a decimal point. It will still be considered as a valid floating point number. And in the exponent form, we have 2 parts, 2 components, the mantissa and the exponent. The mantissa, which is going to be a real form floating point number, followed by the letter E. It can either come in lowercase or uppercase, followed by the exponent, which has to be an integer form. So this is going to be the scientific notation or the exponent form. Now how this is to be read is a 5.4 into 10 to the power 4, a minus 7.2 into 10 to the power minus 5. So the scientific notation or the exponent notation has these 2 components, mantissa and exponent. A complex numerical literal, it has got a real part and an imaginary part, and it comes in the format a plus bj. So if we have a variable that is assigned with a valid complex number, if we have to retrieve the individual components of the complex number, the real component and the imaginary component, we can use x dot real to obtain the real component and x dot imag to obtain the imaginary component. So much about numerical literals. Then we have the Boolean literals. The only 2 values that represent a Boolean literal are true and false, and these are values which are returned when comparison operators are used, comparison or the relational operators. So when we use one of those relational operators or the comparison operators, the resultant will be a Boolean literal, true or a false. And when we use a Boolean literal in a mathematical expression, like in for example, I try to print the value of 14 plus true, then the value true is going to be substituted with a 1, and a value false which is used in a mathematical expression will be substituted with a 0. A string literal is going to be a sequence of characters. So a character will be any valid character in the character set of Python, namely letters, digits, symbols, white spaces. When I talk of white spaces, I'm referring to the blank space, tab, backspace and so on. And all these sequence of characters should definitely be enclosed within quotes. The quotes can either be single quotes or double quotes or triple quotes. And there are two types of string literals that you could represent, the single line string literal and the multi-line string literal. A single line string literal has to have those sequence of characters with the beginning and the ending quotes all on the same line. But a multi-line string literal, as the name implies, can extend across lines. So there are two ways of representing a multi-line string literal, like what's shown here. The series of characters ended with a continuation character. A backslash here refers to a continuation character, and then you come to the next line and continue the string. And the second form of multi-line string literal will be to enclose the several lines of the string within triple quotes. It can be 3 single quotes or 3 double quotes. The difference between these two notation is that, now supposing I have a name that is assigned with, I say hello. Now if I do not have a continuation character and press the enter key, that will throw a syntax error, namely the EOL error, the end of line error. So we definitely should close the quotes here, or we can have the continuation character and then continue in the next line and complete the string, finally give the quotation marks. So if I try and print the variable, then it shall show the value that is stored in the variable. Now there is a built-in function called len, which lets you know the number of characters that are assigned to that given variable. So if I see the length of the variable name, this represents the number of characters that are there in the assigned value. So hello world has got 10 characters. But the other way of representing, which I said, other way of representing a multi-line string, which I said as enclosed in triple quotes. The difference is that I have 3 double quotes. I have the first line and then extend to the next line and finally close my string with the 3 double quote. And now when I see the length of the variable, this will show 11. So that's the difference between multi-line string character constant that's using a continuation character and that which is using a triple quote. The difference in the length is because when I continue to the next line using a triple quote, there is a implicit inbuilt new line character that's going to be included. So if you see the variable, when you print the variable, now this character that is shown here is called the new line character. We're going to be seeing a series of such characters. They are called backslash characters. A backslash character or other names given for a backslash character is a escape sequence character or a non-graphic character. These are some characters which cannot be directly typed on the keyboard, and when you use a variable in a print, you could see the effect of these backslash characters. Now wherever a slash n was encountered, the characters that follow the slash n will come to the will be printed in the next line. So hello and the characters that followed the slash n are printed in the next line. World is shown in the next line. So the slash n is referred to as a new line character. Now there are several other backslash characters. Just to show you as an example, supposing I had a slash t, now that refers to a tab space. So the first few characters are going to be shown, and where the slash t was encountered, a gap of 8 spaces will be shown, and then that will be followed by the remaining characters like that. Moving on, the other types of literals. Now this is just an example that is shown, but more about these literals are going to be explained in detail in the coming videos. A list literal is a sequence of values that are enclosed within square brackets. Now this is called all these are called heterogeneous data types because so like we saw from the earlier slides, so this is a integer value, this is a floating point value, this is a string, this is a boolean literal. A list can contain elements of different data types, that's why it's called a heterogeneous data type. And similarly, a tuple also can have different elements of different data types, but the syntax is these values are either enclosed within parentheses, or it can just be a series of comma separated values. So the parenthesis is not mandatory, but when a series of values are separated by a comma and assigned to a variable, now that is a representation of a tuple. The dictionary is collection of key value pairs. Like I said in detail, all these are going to be covered in the coming videos. We have the syntax of this curly brackets, and then the key followed by a colon followed by the value. So several such key value pairs separated by a comma and enclosed within curly brackets is the syntax of a dictionary. And the last type of literal is a none. This is a keyword as well, and this refers to an empty value. The next token is an operator. Operator is a symbol or a word which does operations on operands. So when I talk of operands, I am referring to the data. Supposing I had 15 plus 3. So the operation that's happening is addition. The operator that is used is a plus, and the data upon which I am performing the operation, that's called an operand. So 15 and 3 are operands. There are different types of operators: arithmetic, comparison, which is also called relational operators, logical operators. Under string operators, we have concatenation and replication operators, and there are a series of other operators called the bitwise, identity, membership, augmented assignment, and so on. There's a separate video covering all these operators and how to manipulate these operators, how to evaluate these operators based on some precedents is going to be covered in the coming video. And the last token is called the punctuator. Punctuator are basically symbols which are used to organize the statements in a Python code. As you do coding, you will come across different symbols that are going to be used. You'll get to know the purpose of those symbols, and as per the syntax, what type of symbol has to be used for which situation. So those symbols, the collection of those symbols are going to be called punctuators. Data types in Python. Now data type is refers to the type of data any programming language lets you use, so that you get to know the type of operations that are possible on data. So every programming language has got these data types. In Python, you can broadly classify the data types as numbers, sequences, and mappings. Under numbers, we have the integer, floating point, and complex. Boolean is also treated as an integer notation because like I showed you earlier, when a Boolean constant, a true or a false, is used in a mathematical expression, it's going to be substituted with a 1 and a 0 respectively. So internally, a Boolean literal is considered or treated as an integer. So it's shown under integer. Under sequence data type, we have strings, lists, and tuples, and under mapping, we have dictionaries. So this is a broad classification. Every data type, the syntax, the usage, and how to use them in a code, they're all going to be covered in the coming videos. And when you talk of a variable or an identifier name, you have two values associated with the variable, the L value and the R value. So like what's shown in the example here, x is equal to 100. So x refers to the L value. L value is nothing but the location value. Basically in Python, we are going to treat a variable as something that points to a memory location. The memory is going to contain, it's like a container which contains some data, and there is something that's going to be pointing to that memory location. So that which points to that memory location is a variable. So that's your L value. The L value or the location value should necessarily be a variable. It cannot be anything else. It has to be a variable. But the R value is a data that's stored in that memory location, in that container. So what all can be an R value? You can have a R value which is a variable. Like for instance, after assigning x is equal to 100, I can say y is equal to x. So again, the L value here is a variable, but the R value here is yet another variable. So when I say this, y is also going to be pointing to the location that contains 100. The R value can be a constant. A R value can be an expression. So R value could be one of this, but the L value should necessarily be a variable. So these are the two values associated with the variable, the L value and the R value. We saw the classifications of data types, but broadly we can classify data types as mutable and immutable. Now, what does mutability and immutability refer to? The value that a variable stores, if the value can be altered after it's been created during the program run, then such a data type is called mutable data type. And from the list of data types that were shown, the list and dictionary will fall under the mutable data type. A immutable data type is the value of the variable after it's been created cannot be altered during the program execution, and that data type is called a immutable data type. And examples of immutable data type will be numeric, tuple and string. Again, what it means by mutability, what it means by immutability, how can the value be altered, how to change the value of the data type is immutable, all that will be seen under the the headings, lists, tuples, dictionaries when we see them in the coming videos. Now we'll see how we can initialize a variable. There are two ways of initializing a variable. It can either be statically initialized or dynamically initialized. What it means by static initialization? When a variable is assigned with a known value, a constant value, when you write the code, that's called static initialization. Say something like a is equal to 500. So I know a is going to be assigned with a constant value 500 when I write the code. But a dynamic initialization is when a variable is assigned a value which is going to be computed or known only at runtime, only when I execute the code. So if I have a assigned with a 500, I'm having a b which is going to be computed as a plus 10. So only when I execute the code, b's value is going to be computed as a's value plus 10. So this initialization, which happens at runtime, is called dynamic initialization. Also, if you're going to input a value for a variable a during runtime using the input command, input function, that also becomes dynamic initialization. More about input output functions are going to be covered in the coming videos. Now, supposing several variables, multiple variables are to be initialized, there are two ways of doing this. Now, if multiple variables are going to be assigned with multiple values, then we can have two ways of writing this using multiple statements, like a is assigned with 100, b is assigned with 150, c is assigned with 180. So in different statements, I am assigning different values to different variables, which also can be written in one single line as this: all the three values, variables and their values along with the initial assignment separated by a semicolon. So three different lines can be clubbed on the same line using a semicolon separator. But in a single statement, if the above initialization has to happen, then syntax is a comma b comma c equals 100 comma 150 comma 180. So a, it takes the value 100, b takes the value 150, and c takes the value 180. Now if several variables are to be assigned to the same value, the syntax will be a equals b equals c equals 500. So all the three variables a, b and c are going to be assigned to the same value 500. Do show your interest and understanding by hitting the subscribe and dropping a like. See you in the next video.